Hello everybody and welcome back to another CS Lightwork video. We are tackling the daily yet again, 2483 minimum penalty for a shop. You are given a customer visit log of a shop represented by a zero index string customers consisting of only characters N and Y. If the ith character is Y, it means that the customers come in at the ith hour, whereas if it's N, it indicates that no customers come in at the ith hour. If the shop closes at the jth hour, so anywhere between the beginning to the end length of the string, the penalty is calculated as follows. For every hour when the shop is open and no customers come in, the penalty increases is 1. So shop is open, no customers come in, that is an N value when the shop is open. For every hour when the shop is closed and customers come, the penalty increases by Y. So that means once it's closed and there's a Y, we up the penalty, right? Return the earliest hour at which the shop must be closed to incur a minimum penalty, and note that if the shop closes at the jth hour, it means the shop is closed at that hour. So we have to look at everything prior. Now your brain might be racing on how to tackle this, but the solution is actually pretty simple. We only actually need to iterate over this once, and we can use prefixes and suffixes. Why is that? Well, we'll look at our jth hour, that closing hour, as the current increment we're at, the current iteration of going through the string we're at, the current almost character, you'll say, the indice, right? And we can start at the beginning, and that means the shop is closed right away. So what does that mean? Any y's after is going to be an increase in penalty, right? Any n is fine because it's after close. But once we move through the string, on the left is when we're open, and so any n's on the left, so any prefix n's is equal to a penalty, and any suffix y, so after close, is equal to a penalty as well. So that's the sort of idea we want to keep in mind: prefix n, suffix y. And all we have to do is now keep a minimum penalty, which we could start as the penalty at the beginning, so it'll be the y count, and all we have to do is iterate through the whole string, right? And all we're going to do is look at the character that we're at currently of that substring, and all we have to do is calculate our suffix, or update our prefix and suffix, and then say, hey, our current penalty is equal to the sum of the prefix and suffix, and if the current penalty is the smallest we've seen before, guess what? Set that to the new smallest and mark the hour that we're at. So mark the current J, and we're going to be returning that J, right? So we're just keeping track of a local minimum and going through all the possible penalties, all of the cases, linear, and keeping track of that best hour to return. All right, so as you can see, here's the code. So first we declare the initial suffix to be the Y count ahead, right? And then the prefix count of n is going to be 0 because we start at the beginning, so we don't need to look at the left. Now the minimum penalty, we'll set it to the beginning suffix and set that best hour to 0, and here we just iterate through. If it's a y, well, guess what? We subtract 1 from the suffix, and if it's an n, which is the else case, we add 1 to the prefix, and then we set that current penalty and say, hey, if it's smallest, set it to the local minimum, and then all we're going to do after that is set the best hour to the current increment plus 1 because the increment started at 0, right? And return that. Now, that's pretty much it for the solution, and the runtime for this is going to be O of n because you only need to go through the string once. That's pretty much it. Love you guys. Take care. Peace. Follow for less.